More notes on section 6.2. So here we go. Let's just make another video. 6.2 is now applications of normal distributions. And now we're just looking at non-standard normal distributions where the mean is not 0 anymore and the standard deviation is not equal to 1. What we did pre-calculator, yes, when I was in school, we basically had to convert and find the z-score and then look at the table. Luckily for us, we don't need to do that anymore because the calculator can just handle any kind of mean and standard deviation. So back in the day, we converted, excuse me, just swallowed something. A bug. We converted the non-standard normal distribution to a standard normal distribution and were able to use the tables. So here's an example. I think it's also in the book from the Tall Club International. That's a true club. It has a requirement that women must be at least 70 inches tall. I swallowed the bug. Yeah, okay. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches. So find the probability or find the percentage probability, kind of the same, of women who satisfy this height requirements. And the height requirements is what? That you must be at least 70 inches tall. Okay, you draw a bell-shaped curve. Then you label all your information. You can see that the mean is 63.8 inches and the standard deviation of 2.6. The mean is smack in the middle of your bell-shaped curve. Right underneath, I usually write the standard deviation. So what are we looking for? We're looking for the probability that somebody is at least 70 inches tall in order to belong to the club. So 68.8 is our value smack in the middle. That means 70 has to be definitely to the right. So greater than 70 means we're shading everything to the right. And now it becomes a matter of calculator, normal CDS, second VARS, normal CDF. My lower bound is 70. My upper bound is the 9,999. Now I have a mean that's 63.8 and a standard deviation of 2.6. And that is 0.0085. Now the book is asking about the percentage. If you have that kind of problem where you're being asked percentage, you have to now multiply the answer by 100, and that's 0.85%. So here's another problem. I think they're out of the book. We're looking for heights between these two values, 64, 77. This time the mean is 68.6 with a standard deviation of 2.8. These are just some examples out of the book. I think this is the pregnancy one. You also have a pregnancy problem in my stat lab. Now, if you're wanting to find a cutoff score, you have to use inf norm. Like when designing aircraft cabins, with what ceiling height will allow 95% of men to stand without bumping their heads in airplanes. Men's heights are normally distributed. Here's your keyword, normally distributed. That tells you need a bell-shaped curve with a mean of 69.5 and a standard deviation of 2.4. Okay, so what is the height that will allow 95% of men to stand? So we're looking for X here. We're looking for X, the height We have 0.95, which is just about the entire bell-shaped curve. We have the men's heights and the standard deviation, in this case inf norm 0.95, 69.5 for the mean and the standard deviation. So this is the area that's given to us already. And that is approximately 73.4. Your recording is done. Okay, check it out later. So if we round to a whole number, yeah, 95% would be 73 inches. There you go. So these are just some example from my notes in chapter 6. Okay, now I need to stop this recording.